Alright, today we're doing 7.5, and that is operations with matrices. So we are adding, subtracting, multiplying by a scalar, and multiplying matrices.
Are we really doing?
We really are.
How much money would it take for us to know?
Alright, so in adding and subtracting matrices, our dimensions have to be the same. So if I had a matrix that was like this, 1, 2, 3, 4, and I was adding it to one that looked like this, could I add these matrices together? No, because my first one is a 2 by 2, and what's the dimensions of the second matrix?
2 by 3. 3 by 2.
3 by 2, remember, row by column. So 3 by 2. So I would not be able to add this. Your dimensions have to be the same. So when adding matrices, we add the corresponding entries. So if I had two matrices that were the same size, and I was adding them together, I add whatever's in the first row, first column, to the first row, first column. I add what's in the second row, or first row, second column, to the first row, second column. So you add the corresponding entries together. If the dimensions aren't the same, they cannot be combined. So looking at example 2a. Can I add these matrices together? Yes, it's a 2 by 2 and a 2 by 2. So since they're the same, we can add them together.
It just has to be 2 by 2?
It has to be the same size. So both of them have to be the same dimensions. It doesn't necessarily have to be a 2 by 2. So we add the first row, first column to the first row, first column. So what's -1 plus 1?
0.
0. Next, I add this first row, second column to the first row, second column. What's 2 plus 3? 5. Then I add the second row, first column to the second row, first column. What's 0 plus -1? -1. And then lastly is the second row, second column, second row, second column. So 1 plus 2, 3. So this would be our answer. So for B, can I add these two matrices together? Yep. What are the dimensions of the first one? A 3 by 1, and the second one's a 3 by 1 also. So since the dimensions are the same, I can add them. So my result is going to be a 3 by 1 as well. So what is 1 plus -1? 0. What is -3 plus 3? 0. And -2 plus 2? 0. All right, for C, can I add A and B together? No. What are my dimensions of A? A 2 by 3, because it has 2 rows, 3 columns. What are my dimensions of B?
2 by 2.
A 2 by 2. Since the dimensions are not the same, we cannot add them. So not possible. All right, next we have scalar multiplication in our matrices. So this is just multiplying by a number out front. When we multiply our matrix by a number, you have to distribute it to everything inside the matrix. So for example, 3, we need to find 3a. So I'm multiplying my matrix here by 3. So 3 is my scalar. So I have to make sure I distribute that 3 to everything inside the matrix. So my new matrix, 3a, is going to be what? What would my first row be? 6, 6, 12. What's my second row? -9, 0, -3. And the third row? 6, 3, 6. Perfect. All right. For example 4, it's asking us to find 3a minus b. So just like we would in normal algebraic equations, we have to follow our order of operations. So we have to find 3a first and then subtract b from that. So I'm going to multiply 3 times my matrix A. So what would my new row 1 be?
6.
6, 6, 12. Row 2. Negative 9, 0, negative 3. And row 3. 6, 3, 6. And then I'm taking 3a, which is the red box here, and subtracting b from it, which I'm just going to rewrite b here so I have it all together. So b is 2, 0, 0, 1, negative 4, 3, and negative 1, 3, 2. So when I subtract these, remember, you have to subtract the corresponding parts. So first row, first column, so it'll be 6 minus 2, which is?
Negative 4.
6 minus 2.
Oh, positive 4.
Positive 4. Then 6 minus 0. 6. 12 minus 0? 12. Now the second row, negative 9 minus 1. Negative 10, bless you. 0 minus negative 4. So remember, 0 minus negative 4, what do you, minus a negative turns into? A positive, so it's a positive 4. So if it helps, write down each step. Negative 3 minus 3. Negative 6. 6 minus negative 1. 7. 3 minus 3. 0. And 6 minus 2. 4. Bless you. So that's our answer. Right, the next one looks a little bit different. We are solving a matrix equation. So here we are trying to find what x is. So x is going to be some matrix. We have to figure out what it is. So I want to rearrange this since I'm given a and b. I'm going to put this in terms of x equals. So how could I solve this for x? Minus a on both sides and divide by 3. So I get x is equal to b minus a over 3. So I now just have to perform this to find x. I could also switch the order of what I'm doing because b minus a divided by 3 would be the same thing as b over 3 minus a over 3. So if I wanted to, I could divide everything in a and everything in b by 3 and then subtract. But I would stick with this one just because, yeah, if I did this way, I'll have fractions. So at least now I just have fractions at the end if I have fractions. So subtract first, then divide. So we have b minus a. Careful with the order because here you may think that since a is written first, you subtract it that way, but it's b minus a. So b is negative 3, 4, 2, 1, minus a, which is 1, negative 2, 0, 3. So when we subtract these, negative 3 minus 1 is what? Negative 4. 4 minus negative 2, 6. 2 minus 0, 2. And 1 minus 3, negative 2. So now I'm dividing this matrix by 3. So instead of dividing by 3, I can multiply everything by 1/2. So I'm going to make my scalar 1/3, sorry. Multiply everything by 1/3 instead of dividing by 3 because it's the same.
How do you like keep change so that we can't read?
Well, you would just divide every number by 3, which is the same thing as multiplying by 1/3. So I'm just distributing 1/3 to everything. So 1/3 times negative 4, negative 4 over 3, 1/3 times 6, 2, 2 times 1/3, 2 over 3, and negative 2 times 1/3, negative 2 over 3. So that's our answer. So that is x. So when it gives you a matrix equation, solve for that variable that you're trying to find. That way you can just perform the operations that are given. All right, next we have matrix multiplication. All right, so in multiplying matrices, our dimensions don't have to be the same. What we need when multiplying is the inside parts to be the same, and I'll show you what I mean by that. If this is a 2 by 3, so let's say I had 1, 0, 2, 3, 4, 5, And this one was 2, 3, 4, 5, 0, 1. So what are the dimensions of my first one?
2 by 3.
A 2 by 3. What are the dimensions of my second matrix?
3 by 2.
A 3 by 2. I need the middle parts here to be the same. So these numbers have to be the same in order to multiply.
What do you mean the middle parts?
The middle numbers here, 3 and 3. The ones on the inside. The ones on the outside are going to be our answer. So when we multiply these together, our answer is going to be a 2 by 2. All right, so looking at example 7. What are the dimensions of matrix A? A 3 by 2. And what are the dimensions of matrix B? A 2 by 2. So are the inside numbers the same?
Yes.
Yes, so that means we can multiply. If they weren't the same, it would be not possible.
It's like neither of them.
Right. Well, the inside numbers, whatever the two numbers on the inside are, have to be the same. Doesn't matter. You could have a 2 by 3 and a 2 by 2. If the inside numbers aren't the same, you can't multiply. Now our result is going to be what size? A 3 by 2. So on the side here, I'm going to draw a 3 by 2 matrix. So remember, it's row by column, so I have 3 rows and 2 columns. So this is the size that my answer is going to be. So this will kind of help keep me in check. All right, now when we multiply row by column. So I'm starting with my first matrix, the first row, and the second matrix, the first column. So in my first matrix, I move in rows. The second matrix, I move in columns. Now when we multiply the first number times the first number. So what is -1 times -3? 3. And then we add that to the second number times the second number. 3 plus -12. So I'll write it down here. That's going to be -9. So next, I can move to I'll go in rows. So next I'll go to the first row, second column. So I multiply the first number by the first number. So -1 times 2 would be -2. And the second number times the second number. 3 times 1? 3. So -2 plus 3? 1. So since this was the first row, second column, that's going to go in the first row, second column spot. So that goes up in the top right corner. Now I'm going to move to the second row, first column. So that's going to go in the second row, first column, this spot. So 4 times -3 is -12 plus 2 times -4, -2 times -4, 8. And -12 plus 8, -4. Right, next, we're going to look at the second row, second column. So second row, second column is this spot here. So first number times the first number. 4 times 2 is 8, and then second number times the second number. So plus -2. What's 8 plus -2? 6. All right, next, I have the third row, first column. So that goes in the third row, first column. So multiply the first number times the first number. -15. Second number times the second number. Plus 0. So -15 plus 0 is -15. And then lastly, I have the third row, second column. So that goes in the third row, second column spot. So first number times the first number, 10. Second number times the second number, 0. 10 plus 0, 10. So this is my answer. All right, example 8. So again, we are multiplying these matrices. The first thing we have to do is check our dimensions. So what are the dimensions of the first matrix? A 2 by 3. What are the dimensions of our second matrix? A 3 by 3. So are the inside numbers the same? Yep, so that means we can multiply them. What is going to be the size, the dimension of our answer? A 2 by 3. So it's going to have 2 rows and 3 columns. So 2 rows, 3 columns. So it's going to be this shape. All right. So first thing we multiply is our first row, first column. So that goes in the first row, first column. Remember, in the first matrix, we move in rows. The second matrix, we move in columns. The first matrix, we move in the rows. So we only go row by row in the first matrix. The second matrix, we move in columns. So what we multiply now is going to go in our first row, first column spot. So I multiply the first number with the first number, -2. Second number with the second number, 0. And third number with the third number. 3 times -1, -3. Perfect, -5. When we add them all together, we get -5. Next, we're going to find the first row, second column spot. So that goes in the first row, second column spot there. So I multiply the first number with the first number. So that would be 4. The second number with the second number, 0. And the third number with the third number, 3. So 4 plus 0 plus 3, 7. So next, I'm going to find row 1, column 3. So that goes in row 1, column 3 spot. So I have the first number times the first number, 2. The second number times the second number, 0.
6.
Third number times the third number would be -3. Because it's the third number here, 3 times -1. Almost. What is 2 plus 0 plus -3? -1. Alright, so let's do the second row, first column now. So that's going to go in the second row, first column spot. So first number times the first number, -4, because it's 2 times -2. Plus the second number times the second number, which is -1. And then the third number times the third number, 2. So -4 plus -1 plus 2, -3. All right. Next, we're going to find the second row, second column. So second row, second column goes here. So first number times the first number, 8, plus second number times the second number is 0. Third number times the third number, -2. So 8 plus 0 minus 2, 6. And then lastly, we have the second row, third column. Goes in the second row, third column spot. So first number times the first number, 4. Second number times the second number, 0. And third number times the third number, 2. So 4 plus 0 plus 2, 6. So this is our answer.